This video is all about isomers in organic chemistry. It's going to be useful for level 2 organic or for review of level 3. All isomers have the same molecular formula, but their atoms are arranged differently, and this generally results in molecules with different names. Looking at C4H9OH, we can make 4 different isomers. When we're looking at isomers, I tend to start off with straight chain. So here is 4 carbons in a row, and then I put the functional group, in this case the OH, on the end. So the first isomer is butane 1-ol. I then move the functional group onto the second carbon, making butane 2-ol. I can't move it onto the third carbon because that would also be butane 2-ol. My next strategy is to move one of the carbons if possible to make a methyl group. And here you can see I've got methyl propane and I've shifted the functional group back to number 1. So it's methyl propane 1-ol. And then again I shift the functional group to C2, making methyl propane 2-ol. And these are the 4 constitutional isomers of C4H9OH. Just want to point out some common errors that occur when trying to draw different isomers. We can draw the main chain in different conformations, like twisted around. To be sure we're not just drawing the same molecule twisted around, we need to name each one to make sure that it's different. So let's take C6H14 for an example. For this molecule, we can make 5 constitutional or structural isomers, each of which has different names. Let's start again with the simplest isomer, in this case 6 carbons, all in a single row. You can see, looking at these examples I've drawn here, that I appear to have drawn this in a different way, but actually they are exactly the same molecule. The top is hexane drawn in one straight line, and the bottom one is hexane drawn around a corner. The next molecules I try is to again take 1 carbon from the end and put it somewhere in the middle, making a methyl group. My 2 examples here are 2-methylpentane and 3-methylpentane. Again, I cannot have 4-methylpentane, as that would be the same as 2-methylpentane. Carrying on now, instead of 1 methyl group, I'm going to try 2, and this next molecule has both methyls off the same carbon, 2,2-dimethylbutane. The only other way I can do this isomer is to have both methyls of different carbons, 2,3-dimethylbutane. And lastly, for isomers, geometric isomers. These are huge in level 2, but we're just revising them very quickly for level 3. There are 2 requirements for these cis-trans isomers to form. Both these requirements must be met. The first requirement is that there must be a C to C double bond, and this restricts rotation, which fixes all the atoms in place. You can see on but2ene here, there is a C to C double bond present in the molecule. The second requirement for cis-trans isomerism is that each double bonded carbon must be attached to 2 different atoms or atom groups. Here you can see each double bonded carbon is bonded to a hydrogen and a methyl group. So but2ene meets all the requirements for cis-trans isomerism. In the next video, we'll look at the level 3 version of isomers, which is optical isomers.